All right, this is the intro video for section 5.4, polynomials. And we're going to start off by defining polynomials. I want to give you the classic definition, and we'll go a little bit deeper here. Polynomial is a multi-termed algebraic expression. This is kind of a quick and easy one to remember. I think we can go a little bit deeper. We could do a little bit better than this. As we're going to do that down here below and fill in some blanks. You could also say that a polynomial is a single term or sum of terms in which all the variables have whole number exponents and no variable appears in the denominator. Okay, so we can also see a table below gives examples of polynomials and types of them. On the far left, we see a column labeled monomials. Monomial means that the polynomial has exactly one term. And perhaps we can look through here and see. We've got one term, one term, one term. Please note that all the variables that are given there all have whole number exponents. For example, this is negative 6x to the first, and 1 is a whole number. The 3 and the 2 right there, those are both whole numbers. And this is technically 11x to the 0. Again, 0 being a whole number. These all fit that polynomial definition because they have one term. We call them monomials. We also have examples of binomials. A binomial is a polynomial that has two terms. And so we can see one term here, there's a second one. There's one term there, there's a second one term, two terms. Please take note that with polynomials, the different terms are separated by plus signs and minus signs, and a term itself is actually held together by multiplication or perhaps division. Okay, if a binomial is two terms, a trinomial must be three terms. And so we can see in this column, I've got 1, 2, 3 terms. 1, 2, 3 terms. 1, 2, 3 terms. They're all trinomials. And then lastly, this final column here, this is where we go above 3 terms. There's not a special name for these, like quadnomial or anything like that. So we just, at that point, we probably just call them a polynomial. A couple of terms we want to be familiar with. First one is descending order. This is referring to the exponents decreasing from left to right. So an example of descending order would be something like 5x to the third plus 10x squared minus 4x plus 28. You can see that the exponents go 3, 2, 1, and then 0. So that's descending order. That's not always required, but it's very useful and in the near future really will be required. And then the lead coefficient is, really the lead coefficient can only be determined when the polynomial is in descending order. So if we take the previous example, which is in descending order, the lead coefficient would be the first coefficient you come to. In that case, it's a 5. Let me give you a kind of a counterexample to that. If I had something like this, 3x plus 8x squared minus 11. And if I were going to look for the lead coefficient there, I might mistakenly say, hey, that 3, that's the lead coefficient. But that's not the case. In order to judge the lead coefficient, we have to be in descending order with our polynomial. So descending order would be 8x squared plus 3x minus 11. And so once we write this polynomial in correct descending order, we can see that the lead coefficient would be 8. And then there are some examples of expressions that look like polynomials but really aren't. I'll give you a couple of those. So 8x to the negative 3 certainly looks like a polynomial, but the exponent on the variable is not a whole number, so that makes this not a polynomial. Another example would be 7x to the 1/2. Again, kind of looks like a polynomial, but because the exponent is not a whole number, this is not a polynomial. And even things like 12 over x squared kind of looks like a polynomial, but remember the definition of polynomial says that you cannot have variables in the denominator, and that does. So once again, because of that, this would not be a polynomial. A couple more terms here, and then we'll do a couple of activities. So degree of a term is the value of the exponent on that variable. So, 12x to the fourth, the degree is 4. It's the same as the exponent. Negative 3x to the ninth, the degree on that term would be 9. I'm going to take a look at one more aspect of degree on the next page. The degree of a polynomial, so not just one term of the polynomial, but the whole thing, the degree of the polynomial is the same as the degree of the highest degreed term. So a brief example of that would be 12x squared plus 8x minus 9. For the first term, the degree is 2. Second term, the degree is 1. Last term, the degree is 0. The highest degreed term was 2, and so the overall degree of the polynomial is 2. Okay, so armed with all of that, let's see if we can do this example here where we describe the polynomial. So if you can, pause the video, try this, and we'll look at the answer here in just a second. Okay, so describing the polynomial, first of all, we're supposed to list out the terms. I see 3 different terms. The first term would be n to the 7th. The next term would be negative 2/3 n cubed. The last term would be negative 9. Okay, so the coefficient on n to the 7th, well, since there's not one written, we understand it to be a 1. The second term, the coefficient is negative 2/3. And for negative 9, it's a constant. And so the whole term is kind of the degree, or excuse me, kind of the coefficient there. Okay, and then lastly, degree. The degree of the first term is 7. The degree of the second term is 3. The degree of the third term is 0. And then, type of polynomial. Well, there's 3 terms, and so this would be a trinomial. Degree of the polynomial, well, the 3 degrees are over here, 7, 3, and 0. The degree of the polynomial is the same as the highest degreed term. That would be 7. And lastly, the lead coefficient would be the coefficient on that highest degreed term, and that was a 1. Okay, there is one last thing that we can do with this, or that we're going to do with this here in this video, and that is evaluating polynomials. And I included this here. We've done this before, maybe not with this exact terminology, but this is an evaluation. We've done many evaluations. I just want to remind you how this works. So it says evaluate this polynomial right here for x equaling negative 2. The first thing I'm going to do is I'm going to replace all my variables with empty parentheses. And once I have done that, I am going to replace those replace the emptiness there in the parentheses with the number that I'm supposed to plug in for x. So negative 2 goes in here, here, and here. Once I've done that plug-in, that's a step you definitely want to show, definitely want to use that to your advantage. Now I'm going to follow order of operations and evaluate this. So I'm going to do exponents first because there's no work to be done in parentheses. So negative 2 in parentheses cubed is negative 8 minus 4 times negative 2 in parentheses squared is positive 4. Still have plus negative 2 there, and then minus 1. Once I have done exponents, I'm going to multiply. And so I see this 1 multiplication here. And I'm going to go ahead, well, I'll write this as plus negative 2. That'll be fine. And once I have done that, I'm going to, once I've completed the multiplication, I'm going to go ahead and add and subtract, just following PEMDAS. All right, so this ends up being negative 24 plus negative 2 minus 1. This ends up being negative 26 minus 1, which leads us to negative 27. Okay, hope you've learned a little bit about polynomials. We'll keep working on these when I see you in class next time.